there's my part C answer. So this is part C. Now, for part D, it says at least one non-defective. So if it's non-defective, what does that mean? Non-defective. That means it's good. So we're doing the probability of at least one good. So that means it's going to be 1 minus the bad. So we're going to do 1 minus the bad, which was the answer to B. So we're going to do 1 minus 0.000007613, blah, 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 blah. So if I come over here and do 1 minus 0.1234566, can't remember what else it was, 13826. 6 zeros. Yeah, 2, 4, 6 zeros. So this would be my answer to D. Now, I'm not going to do the last problem in this section because this is a good review for us to do next time. It does the regular probability, it does the given probability, which is the conditional, it does the or, which is the overlap, it does the and, which is the overlap, it does the or, which is everything. So I'm going to use this one to do as a review on Tuesday, so I'm going to skip that one. We'll come back to that one. Now, I love this section. I use this all the time. Like when I'm riding down the road, since I have a monogram business, my daughter and I are always like, oh, what is this? When we're riding down the road and we're looking at license tags, and we're looking at like the initials. You know, it's on license tags in South Carolina, it's 3 numbers and 3 letters, or 3 letters and 3 numbers. And so we ride and we look at, like, we'll see the initials OPN. And so I'll make up a guy's name initial, and she'll make up a girl's name initial. We do this all the time.
Wow.
I'm like, Oscar Nicholas Peters. And then she'll come up with the girl's name. And we always get stuck with, like, crappy letters. But we do monograms all the time, so it's like we always come up with monogram initials. So I always think, how many different license tags could there be? Have y'all ever thought about that?
No.
A lot. Too many. Now in South Carolina, it's just three letters and then 3 numbers. In North Carolina, it is 4 numbers and 3 letters. If you go to states like California, and it has the county above it. Mississippi has the county above it. Because the bigger your state, because people own multiple cars. We have 4 cars. So you've got to have places for this. So this talks about phone numbers. Like back in the day, when I was little, and I'm like the oldest person in here, you didn't have to dial the area code. You just dialed 332-6941. You just dialed the number. You didn't dial the area code.
I remember doing that.
You remember doing that?
On my house phone.
Yeah. I mean, in Hartsville, we didn't even have to dial 383 or 332. We just dialed 2 in the number and 8 in the number for 383 or 332. And then, back when I was young, it was just 843 and 803.
Yeah.
And then recently, we added the 864. Why did we do that? More people, more phones, more phone numbers. Everybody back in the day just had landlines. Now people are getting cell phones. And you know, I'm leaving Verizon back in the day. I'm leaving Verizon, I'm going to AT&T, and they wouldn't let you keep your same number. So you had to get a new number.
Things were simple back then. They ain't simple no more.
No. So they ran out of numbers.
Yeah.
Well, how many numbers does it happen when you run out of numbers before you have to get a new area code? That's what we're talking about now. Oh! So, I'm so excited. Okay, let's talk about license tag for just a second. I just think these are cool. So if you have a license tag, we have a number, and a number. Or is it a letter? I think it's a letter. We have a, yeah, because we do the letters. Why did I write a number when it's supposed to be a letter? We have a letter, and a letter. And then we have a number, and a number. That's how South Carolina license tags are. So I want to know how many license tags can we hand out before we have to start coming up with something else, before we have to start adding another letter, or before we have to start adding another number, or before we have to start putting Darlington County, Marion County, Florence County. So what we do is we have to come up with how many different choices are there for each blank. So how many different letter options do we have for the first blank? 26 letters we have to choose from. How many different letter choices are there for the next one? Can we repeat?
Yeah.
Because have we seen license tags that are AAA?
Yeah.
So we can repeat. How many different letter options are there? 26. How many different number options are there? We can do a 0, a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, and a 9. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different options of numbers. How many options of numbers do we have there? 10. How many different options do we have there? 10. So if we multiply all of those together, that would be 26 times 26 times 26 times 10 times 10 times 10. That is how many different license tags we can give out in the state of South Carolina before we start doing duplicates. Isn't that cool? A lot of times they reuse them, like if somebody dies and doesn't use their car anymore, if somebody turns it in and says, I don't need this, they'll reuse it then. So some of them do have to be reused if they're not in use anymore. But like North Carolina does a letter, number. So they threw in one more letter, so they're still 26, 26, 26, 10, 10, 10. But because they threw in one more letter, they have an extra 26. So if I take what we have and throw in an extra 26, so by throwing in one more letter, they made a whole lot more license tags. Isn't that cool? Now, then we can say, what if they don't repeat it? So what if we said, once you put an A in your license tag, you can't put another A. Or once you put a 5 in there, you can't put another 5. So what if I said they could not, in South Carolina, what if we said we made a law that there's no repeating in a tag?
26, 25.
It would be 26, I said if they did. 26, 25, 24. 10, 9, 8. So if we did that, it would be 26 times 25 times 24 times 10 times 9 times 8. So we lost about 6 million in the repeating. Isn't that fun? Fun, yeah. You say so? Okay, so that's what 4.4 starts out by talking about. This one's talking about area codes. So when you have a phone number, we have like 843 319 dash blah, 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 right? So it says area code, so this would be called the area code. And then this is called the exchange. The 616, the 319, the whatever you want to call it. And then you've got the last four numbers. Now, it says that for area codes, they allow the use of the digits 2 through 9. So you cannot use the digits 1 or 0 in an area code. Oh, for the first digit. So area codes cannot begin with a 0 or a 1. Okay, so how many choices do we have for this one? So that cannot be a 0 or a 1. So we have 8 choices there. Yay? The second and the third digits can be any of those numbers. So how many choices do we have there? 10 there and 10 there. Now, it just says first, so for part A, it says how many different area codes are possible. So for question A, we just want to know about the area codes. And area codes would be 8 times 10 times 10. You with me? So if I do 8 times 10 times 10, there's 800 area codes. So across the United States, there is 800 different area codes we can use with 3 digits, and the first digit cannot be a 0 or a 1. Now, how many different, okay, that's question A. That same rule applies to the exchange numbers. So that means this would be an 8, this would be a 10, and this would be a 10. Which are the 3 numbers immediately preceding the last 4 of the phone number. Given both of those rules, how many 10-digit phone numbers are possible?
800.
So what are the last 4 digits going to be? 10, 10, 10, 10, because they didn't give me any rules for those. So when I go to my calculator to figure out how many numbers can I have in the world, scroll down so that I can see it. It's going to be 8 times 10 times 10 times 8 times 10 times 10 times 1, 2, 3, 4. One, two, three, 1, 2, 3, 1, 2, 3.
That's the world or
In the United States, my bad. That many numbers in the U.S. That was question B. B. Now, C says, given these rules apply to the U.S. and Canada and a few islands, are there enough possible phone numbers? Assume that our population is 400 million. So how would I figure out?
That's 6 billion, right?
So if I do numbers divided by people, 640000000 divided by 400. Number one, we can see that the phone numbers are more than the people, right? So we know there's more phone numbers than people.
Yeah, because some people will use 2 phone numbers or more.
So this is saying that we have enough phone numbers so that each person right now can have 16 phone numbers. Each person can have 16 phone numbers. But if you think about it, think about businesses. Businesses have a bunch of lines. Radio stations have a bunch of lines. We have house phones. Some of us have landline. I don't, but some people have landlines and cell phones. Some people have multiple cell phones. So even though we're saying, oh, I have 16 lines, not really. If you think about, all these World Trade Centers or like stock exchanges or whatever, they have a bunch of phone numbers. So, I mean, we may run out one day, and we may have to do some kind of different phone system. Add an extra number, add an extra whatever. All right. A thief steals your ATM card and randomly tries to guess your correct PIN number. Your PIN consists of 4 digits. They must be entered in the correct order. Repetition of the digits is allowed. What is the probability of a correct guess on the first try? So, probability means what makes me happy over total. So I've got to figure out how many total tries, how many total answers are there. So, how many choices do I have? How many slots do I have? I have 4 slots. How many choices do I have for the first answer? 10. How many do I have for the next answer? Because somebody's password could be 3333, right? So there are 10,000 different PIN numbers, or PIN ways to type in. So what is the probability that he is going to guess it on the first try? 1 out of 10,000. So do we think he's going to steal your money?
No.
No. And if we wanted to, we could do 1 divided by 1e to the 4th, so that means 0.0001. So there's a 0.01% chance that he's going to steal your money. Probably ain't going to happen. All right, let's look at this one. Radio call letters. If a radio station call letters must begin with a K or a W, they must include 2 or 3 different letters. How many different possibilities are there? Like WNOK, what are some, give me some radio stations.
Station 92.9.
92.9.
6.3.
Yeah, but when they call them on the radio, they'll say this is,
Nope.
I know, 93.9,
I think like
103X.
106.3, I think that's like Win 106.
Win 103, yeah, they usually, their official name is like Win 103X or whatever. So, when you have a radio station, it has, the first is either going to be a K or a W. Then, you're going to have another letter, and possibly another letter. Okay? So, how many choices do I have for the first blank? I only have 2 choices, either a K or a W. How many do I have for the next blank? 26. How many do I have for the next blank? 26, because they did not tell me that I could not repeat or could repeat.
Where'd
So
you
we're,
get 26 from?
how many letters are in the alphabet?
Oh.
Okay? Now, here's the kind of tricky one. This last blank could be a letter because it said 2 or 3 additional letters. So it's got to have 2 letters. It could have 3 letters or it could not have 3 letters. So it could be a letter or it could be blank. Meaning there couldn't be anything there. You with me? So if it's a letter, how many choices do we have? 26. If it's blank, that's 1 choice. So there's a total of 27 for that one. 26 letters or a blank. That's 27 choices. So the first one is going to be either a K or a W. We have to have 2 letters, which is 26 and 26. The third one, it may or may not be there. So 26 if it's there, or a blank space if it's not there. That's our 27. So, it is going to be 2 times 26 times 26 times 27. That is how many different call letters there are if you're in a radio station. All right, I'm going to let you do this one. How many zip codes are there? How many zip codes are there? And the actual question is, what is the probability you will guess the author's zip code? What is the probability that you will guess the author's zip code? Probability that you will guess the author's zip code. It says there's 5 digits. Repetition is allowed, so we can have a zip code of 2222. 22222. So how many choices do we have for the first number? And the next number? So there are 1, 2, 3, 4, 5. There are 100,000 different zip codes. Now, that really wasn't my question. My question said, what is the probability? The probability of me guessing his zip code is 1 out of 100,000, which means it probably ain't gonna happen.
So you wouldn't do the 5 because that's 5 digits?
No, no. The 5 was just be telling me how many total, but I'm not guessing, when I guess those 5, that is 1 zip code.
Okay.
Yeah. Cool? Now we're going to learn about happy numbers. Five exclamation point. Y'all ever seen exclamation points behind numbers? Those are called factorials. Factorials. When you have an exclamation point behind a number, it's a factorial. It doesn't mean that it's happy or excited. Okay? Factorials in math means that you're going to start with that number, so you're going to start with 5, and you're going to multiply it by every number that's behind it. So you're going to do 5 times 4 times 3 times 2 times 1. So 5 factorial means 5 times every number below it. So 100 factorial would be like 100 bottles of beer on the wall. 100 times 99 times 98 times 97 times 96 times 95, all the way down to times 1. Okay? Now, good news is we have a button for this, just like we have an app for this. We have a button for this on your calculator. We would go to math, hit the math button, over to probability, and down to number 4. I'll pull it up and show it to you. Hallelujah. So if I want to do 5 factorial, I would type in the 5 first. Then I would do math, over to probability, because we are doing Ann's favorite, probability. And I would go down to number 4. And I just did 5 factorial. And just to show you, that is the same as 5 times 4 times 3 times 2 times 1. Cool? Alright. Now, DJ Marty T is hosting a party tonight. He has chosen 8 songs for his final set. how many different 8-song playlists are possible? Song orders matter. If the 8 songs are randomly selected, what is the probability they are in alphabetical order by style? Okay? So, we have 8 songs. He's going to play all different songs. Different means there's no repeat. So he can't play the same song over and over and over again. He's going to play all different songs. So he's going to play all 8 songs. 1, 2, 3, 4, 5, 6, 7, 8. So how many choices does he have to pull for that first song? 8. And once he plays that first song, how many's he got? And then once he plays that, so this one would be 8 factorial. So we would do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or we would do 8 math over to probability, and down to number 4 we would do 8 factorial. So there is 40,320 different ways that he can play 8 songs without repeating. Now, that was question A. Question B says, what is the probability that they are in alphabetical order? How many different ways can we put them in alphabetical order?
2.
If there's 8 songs, how many different ways can you put those 8 songs in alphabetical order?
8.
There is only one way to type them in alphabetical order. Like if I have 8 albums,
Oh, there's one alphabetical order.
if I have 8 albums and I want them in alphabetical order, I want to play them in alphabetical order.
There's only one.
There's only one way to play those songs in alphabetical order.
There's not 2 types of alphabetical order.
Right, there's only one way. I'm going to play the A song, and then I'm going to play the B song, and then I'm going to play the H song, and then I'm going to play the M song, and then I'm going to play the T song, and then I'm going to play the X song, and you with me? So there is only one way to play the ABC songs. And how many total ways are there? 40,320. That's going to be my B answer. Yay? All right, do any of y'all play Sudoku? I can't either.
My mom could, my grandma could do it.
I know. Okay, for those of you who don't know, I can't play it, but for those of you who don't know, you have these little baby boxes. And in these baby boxes, you have to have the numbers 1 through 9. And then across here has to be 1 through 9, and then here has to be 1 through 9, and down here has to be 1 through, there's all these 1 through 9 things. And there's like other rules too, isn't there? Does anybody in here play? It's gotta be 1 through 9. Okay, rows and columns, they all have to be 1 through 9s.
I heard somebody say you couldn't erase after you put the number in.
I'll be down.
Oh,
So, you've got to have that was just videotape. You have to have you have to have 1 through 9s in the box, and 1 through 9s across, and 1 through 9s every which way. So, it says, how many different ways can the first row of a blank 1 through 9, so how many ways can we get 1 through 9 on there? So, you have 9 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if they were all blank, how many choices do you have for that first blank?
9.
And once you put that there, 8, 7, 6, 5, 4, 3, 2, 1. 9 factorial. This is why Miss Cooper cannot play this game. Now, watch this. If I do second enter because I'm too lazy, and I back that thing up and change that to a 9, I didn't have to do that. Y'all, that is how many ways there are just to do that one row. No, that ain't happening. Yeah, that's why they give you some numbers. Yeah, no. Mm-mm.
It's still not a deep.
That's still a lot of thinking. Okay, next thing that I'm going to kind of bring up and start you with is permutations and combinations. The main thing that you have to remember with permutations and combinations is that permutations order matters. Combinations order does not matter. And down here, it kind of gave you a little hint. It says permutations are